In this video, we're going to be talking about solving equations with variables on both sides of the equal sign. This tends to be the last part of solving these things, the last little trick we have to do. But also, it seems to be the most troublesome because we kind of get things mixed up, so please pay attention. So when we're looking at some problems, and here's the first one. If you notice, on opposite sides of the equal sign, and I drew a line down the middle of the equal sign, we have variables on both sides and opposite sides. This is different than what we've seen before when we had x's on the same side. When we see something like this, instead of just combining this and making it 6x, just like when the numbers were on opposite sides, we have to add opposites. So I want to add negative 2x to both sides. Copy everything down now. 4x minus 2x is 2x. We did nothing with the 5. We did nothing with the negative 3. Now we see that we have the x's on the left, so I want to get my numbers to the right. So again, I'm going to be adding opposites again. Negative 5 and negative 5. This time it's just the constants. So we're left with 2x equals negative 8. And then our final step, we know we divide by the coefficient 2. And we get an answer of x equals negative 4. Now it doesn't matter which side we take the variables to. It's either the left or the right. It's your choice. Whatever you thinks it's easy. On this problem, I'm going to actually add a negative 3x to both sides. That's a smaller number, and I actually prefer to divide by positive numbers rather than negative. We could add negative 8x to both sides, but in this case, I'm going to add a negative 3x to both sides first. I can now bring down my negative 4. 8x minus 3x is 5x. And I bring down the 16. I know when I add opposites again, but this time I have my x's on the right, so I want to bring my plain numbers over here to the left. So we add negative 16 to both sides. Negative 4, negative 16 is negative 20. And now we divide by 5 to get negative 4 equaling x. Again, it doesn't matter what side the variables are on, as long as you get variables on one side and numbers on the other side. Look at number 3. We have 5x plus 8 equals x minus 22. So when we're looking at this problem, again, hopefully we recognize that we have variables on both sides. So we want to start by adding opposites of the variables. We want to make sure we get variables to one side. The number out in front of here is a 1. There's an invisible 1 there. So we have to add the invisible 1 there. The opposite of it, which is a negative 1x. We get 4x plus, bring down the 8, bring down the negative 22. Bring the plain numbers to the right. This ends up being negative 30, and we have 4x here. Divide by 4. And when we simplify this, we can divide both of these by 2 in order to get negative 15 over 2. Okay, if you're allowed to use decimals, you can divide this out, and you can make it negative 7.5 as well. So again, we can have fractions. Last problem that we're going to talk about. We have 9 minus 4x equals 3x minus 40. Same steps. We see that we have variables on both sides. So again, I'm going to add opposites. Because the negative 4x is smaller than 3x, I'm going to add the opposite of a negative 4x. Copy down the 9. 3x and 4x is 7x minus 40. I can now add a positive 40 to both sides. And I have 49 equals 7x. We then divide by 7. And we get an answer of 7 as well. So hopefully these 4 problems help show you what we need to do when we have variables on both sides of the equal sign. See you next time.